Hello, folks. Welcome to the Land Tamer stream. We've got 6 days to go. We've got some strategy to talk about. I'm going to talk a little bit about F5, which I haven't really done much on this channel, but it's one of the areas that I do a good bit of work in. And we're going to talk about congestion avoidance mechanisms. Just kind of as an overview, I'm going to try to explain that a little bit to the viewers as a favor to me. I'm going to do this, broadcast it, but really it's just me trying to give a presentation to ensure I'm solidifying my knowledge, right? But hey, I want to give a shout out first. This alert came in like right before the stream started, and so I don't think it didn't make the stream, but there we go. Thank you, Delta War 567, for your subscription, your Amazon Prime sub. Appreciate that support, sir. 2 months in a row. Thanks so much, folks. Any small revenue we get, we're going to basically put it back into the stream and make it better. I want to get some lights or some other stuff I want to do to improve the quality of the stream as time goes on. But thanks so much for the support. I really appreciate it, Delta War. You're a good man. All right, so tonight's topics. By the way, wallpaper of the day. I saw this today on NASA's image of the day. This is, I guess, where there's some thawing going on in the Alaskan Chukchi Sea. I guess that's how you pronounce it. Phytoplankton are emerging kind of through the ice. Pretty wicked picture here. I don't know exactly what's going on, but whatever it is going on, it looked really cool. I thought it made a good wallpaper of the day. But yeah, so F5. One thing that I want to talk just a little bit about load balancing. Not a lot, but it's not pertinent to the CCIE. But Regex is, and I did come across the scenario today where, I do a good bit of F5 implementation and support, and one really important thing about load balancing is not just balancing the load. That's not generally too difficult to configure. It's pretty simple. Once you understand all the different objects, what they do, how they are strung together. Most people go for some of the standard built-in load balancing algorithms, whether that be round robin or least connections for each member, things like that. It's pretty simple. I have done some more complex load balancing algorithms based on the F5 does have a scripting language, TCL, which we all know and recognize from routers. You can run TCL scripts. You do the same on F5, and these are called iRules on the F5, but they're scripting, and they can do all sorts of things. I mean, it's pretty much limitless. And there are ways to utilize scripts to examine content and redirect traffic based on the actual payloads, right? So there's things like that, but today, some of the real magic of the F5 platform in particular and other load balancing technologies is the health monitoring, the health checks. That's where a lot of times it pays for itself, is on the health monitoring. And the reason I say that is because, essentially a lot of times the F5 or another load balancer is acting as a proxy in front of traffic. In a lot of cases, not always proxying the traffic, but what it's doing is, it's making decisions about not only where to send the traffic, which node or which member of the pool to send the traffic to, but it's constantly monitoring. Is that, pool member healthy? Or do I need to take it offline and alert someone and not cause issues for users, right, who are utilizing this traffic path? And it's always been, I've always emphasized to requesters, and we have certain sort of policies in regards to what's required if you want a new virtual server, or VIP, as some people say. We can be pretty strict on health checks because no one likes to get those service calls, or that there's an outage because you had a couple of, let's say it's a web pool, and you had a couple of members go down because, the custom or the built-in monitor that someone selected that's just checking, can I ping the device? It's pretty much a useless health check. But I've seen it done. Another health check that is used sometimes is, thank you, Show. Your reviews lately have been awesome. Wow, look at that content. Good stuff, man. Thanks, man. You've kind of inspired me a little bit too, Show, to try to, not just vlog, but offer some tidbits as well, something of value to the viewers. So hats off to you too, my friend. That's how we working together, help each other to make things better, right? So yeah, I've taken a cue from you on that as well, my friend. Appreciate that. But yeah, so on the health checks, it's really, you got that right. So yeah, you've got to, with your health checks, be as specific as possible. Oftentimes the best approach is the person who designed, built, coded, whatever, the application is usually the best person to design a custom-built health check monitor that the F5 can talk to. For example, a lot of people will, let's say it's HTTP or HTTPS traffic that is behind a load balancer, and instead of, well, the best thing is for the developer or the developers to come up with some sort of internal health check that will display the results in our URL, behind that node. So it could be node IP / healthcheckstatus.html. And so in that way, they're kind of custom building a health check that the F5, all it has to do to monitor is look at that specific URL and look for a specific return code or something like that. And that's a very simple type of health check that you can be done that can be very sophisticated, right? Because there's another feature of the F5 health check system where one is, if I see this response from an HTTP GET request, if I see this particular text, that says healthy, that means that the developers run their application and it's coming back with a healthy check. And so it's healthy to send traffic to. You can also do a look for a down code. So if the developer, they can put, let's say they want to do maintenance, they can maybe flip a switch. Then when the F5 goes to that particular URL, the response code, instead of healthy, it's going to say maintenance. And then the F5 could say, okay, I need to take this out of the pool. And if all the nodes are out, you can configure the load balancer to do HTTP redirect to like a splash page or a maintenance page. That's generally the best approach, where the developers are heavily involved and they're actually giving you built-in health checks. Outlook Web Access, for example. You can download, the F5 has what are called templates that you can download where F5 is working with Microsoft, and they've come up, behind an F5. These are the compression types you want to use. This is the load balancing algorithm. This is the custom health check that we're going to use. But when it's in-house, when you're working with in-house developers, like I know in our company we do, we're a software company in a lot of ways. So that's the best way to go. But sometimes you don't get that, or sometimes you have a legacy application. So developers are long gone, and you've had an outage, for example, and you get a team together and you say, okay, this is behind an F5. How can we avoid user outages, and let's find a better health check? And that can get sophisticated sometimes, and that's where Regex comes in. I'm not going to go into all the details of that tonight, but maybe I will in future vlogs. Maybe I'll get at some point after the CCIE. You can get through your account manager. Generally, you can get a free virtual instance of F5. And Big Abe, hey Big Abe in the house. I do like F5. Need to learn more about it. Man, there's so much that this thing will do. And again, if you just pull it down out of the box and do the basic stuff, it's a great piece of technology, but there's a lot of sophistication to it. And not to get it too complicated, you can overcomplicate it, but it's really there to make your life easier if you use some of the tools that it has. In a lot of cases, to avoid outages, So like in this case, you have a legacy application. I've had some that I've dealt with that are very interesting. Sometimes you find out about, we'll talk about Microsoft WCF, for example. Microsoft came up with this load balancing sort of technology on their own a while back. It's sort of software based. It's called Windows Communication Foundation. And some applications, I don't know how much is used anymore. Like a lot of people are using RESTful APIs, or they're doing SOAP. WCF, I think, leverages SOAP to an extent, but sometimes software developers will try to build in their own load balancing technology, and that can be good or that can be bad depending on how they wrote it. WCF gets a lot of flack because it's not really, and it doesn't cooperate well behind load balancers oftentimes, and it's just is one of those initiatives by Microsoft that maybe had a good intentions, but it's not really turned out very well. So, at least in my limited experience with it. But you sometimes have a legacy application and like that, and you need to come up with a little more sophisticated way to find out that node is down, right? Because it might give an HTTP a basic response. The page might come up. But there's other things going on that you can sort of try to find ways to duplicate what will happen to a user to know, to be able to identify and mark that user as down, take it out of a pool, alert your operational team so they can know, okay, I need to go reboot the node or check it or do whatever. So, and again, health monitoring to me, that's the big, and if you go to a class on F5, I've been to one class on F5 a while back, and health monitoring is where the F5 can make its money, in a short period of time, right? Saving you downtime and outage calls. So anyway, one of those features of the F5 is beyond just using a TCL script. You can, in the basic F5 health monitoring, in your response field, you can use Regex. And I was like, okay, cool. I think I'd known this before, and I might have actually done some of this before, but it's been a while. And I was like, okay, sweet. I know a little bit about Regex now. And it was really nice how studying that, and how in BGP, for example, I guess a long time ago, they decided, what are we going to use as an engine to query and check, to query a set of data and obtain a result. And at some point, they decided with the BGP protocol to utilize Regex. Good decision. And it is very simple, I say simple, it's not necessarily simple. But it's a very core sort of technology that is permeated in a lot of different tools. And here it is in the F5 and health check, where I was looking for, I wanted to sort of do an expression. And this is one of these more in-depth sort of health monitoring initiatives I'm with on a legacy application. And I wanted to be able to look at a JSON file coming back and sort of look. One of the challenges was, okay, we've got this standard user URL, and we want to look for this particular text responses. And you can do that with Regex. Mentor says F5 Big IP is great. It is, man. It's not cheap. You can do some of this stuff for less, but do you want to? Can you afford to? That's the thing. Can your business afford to? But another thing about, let's see, I was going to mention something about the Regex expression. Oh yeah, and so the developer also came up with a page where it's sort of a hardware status page URL. And I don't know if it was already there or if he custom built it, but he actually has the page shows the status. It'll show like the node name. It'll show the amount of free RAM, which is cool. But in order for me to manipulate that, I have to parse it somehow with a regex expression. I have not figured out how to do it yet, but I'm going to work on it. It's kind of an interesting regex challenge, but it's fun stuff. I've really enjoyed working on this little challenge I've had lately on it. But yeah, regex, it's great for BGP. It's great for F5 health monitoring. And of course, it's great. I've seen it in other places too in my career. So learn that regex. Moving right along, folks. Written exam. That's what I've been working on tirelessly this week. Every pretty much free moment that I have. I am a little bit worn out today. I think that's because, I don't know. I want to have a good, you have to plan out when you're going up a hill. When do you accelerate? You have to plan your speed correctly. You have to plan your pacing. So I've been going pretty hard, and I think I'm okay. I may take a little bit of rest tonight or tomorrow. A little, not much. Just so that going into the weekend, I've got some good momentum, stamina and strength-wise. It could have to do with the fact this morning's workout was ridiculous. And at the gym, they put this thing on me. They were trying out this thing where they put the little electrical nodes on your muscles, and it causes it to, I was doing this uncontrollably for a while. I tried the machine out. It's pretty cool. It rushes a lot of blood into your muscle systems, and it was pretty slick. Yeah, man, you're in the fog of war at the moment. Once the smoke clears, you'll know when to strike. I love it, dude. Mentors, that is awesome. It's like someone, one of those games where someone throws a smoke grenade and you're just waiting for it to clear before you launch your attack. Yeah, I love that, man. That's great. I'm going to use that. I'm going to steal that. Cool, man. Good stuff. But as a result, last night, I said, okay, I need to get a little more clarity on these congestion avoidance mechanisms. For example, what's the difference between weighted tail drop and weighted random early detection, etc.? So I'm just going to share a little bit of that tonight, just to kind of give myself a little bit of reassurance that I've got a better understanding of it. Tip your bartender. I'm here all night. Definitely tip your bartenders. Lol. That's good, man. I appreciate that. Laughing is good too, man. You gotta laugh. So yeah, let's just review these real quick, and I may not be super clear, but I guarantee I'm going to give you a couple of links that are good in case you want to understand a little better. But why do we need congestion avoidance? Well, two of the problems we're trying to solve specifically are TCP global synchronization, which of course is, we all know how TCP control mechanism works. TCP will do a slow start. TCP is using various algorithms to try to push as much data reasonably that it can through the path. And when it gets back certain signals, like a reset or a certain number of sequence numbers lost, what it's going to do is it's going to back off. And that's fine for a single TCP connection or a group of TCP connections, but often what happens is, let's say you have a site that has a single router, hopefully you don't, but let's say you have a single router that has a single uplink, and the egress interface on that router suddenly gets oversaturated. Well, it's going to have to start dropping packets. And oftentimes, if you've got 1,000 TCP connections behind that, inevitably, a lot of them are going to get that signal that something is wrong upstream. You might even get a congestion notification packet back, and a lot of those connections are all of a sudden going to go back to slow start. So you're going to go from a completely saturated connection to very little utilization, and a lot of people noticing their applications running slow. They kind of get synchronized to slow start. That's what the global synchronization is. Another condition that this congestion avoidance is for is TCP starvation. So UDP don't care, right? So you got a bunch of UDP traffic going. There's no, control. There's no control protocol really in place at the networking level, the network layer. So it's just going to send, and TCP in the meantime is going to be getting signals back that there's congestion, and so that's what you call TCP starvation, where you've got TCP is reacting to the network conditions, UDP is not, or UDP is kind of utilizing more than it should of the connection. It's kind of overpowering TCP or other protocols. So those are two kind of issues with TCP and congestion on the network. So there are a couple of different avoidance mechanisms that are in place to help with these scenarios, right? One is weighted tail drop. So tail drop, oftentimes queues or egress queues on an interface are, it's just a first in, first out queue, right? So generally if the buffer fills up, and the queue fills up, then anything coming in on the tail end is what is getting dropped indiscriminately, right? That's tail drop, just straight up tail drop, right? Weighted tail drop is a little bit of a smarter way to handle that. And it's generally used, and I'm going from lower level of sophistication to higher level of sophistication here, starting with weighted tail drop. So it's still tail drop. However, on a lot of catalyst switches, this is used where weighted tail drop is going to monitor the egress queues and set certain thresholds for traffic classes or IP precedence values. So it's going to say, okay, I've got 100% is, here's the calculated number for 100%, but I'm going to say that for this lower class of traffic, let's say traffic class, IP precedence value 0, that I'm going to start tail dropping some of that traffic when it hits 40%, right? So in other words, I'm not going to wait for the entire interface to fill up to 100% with all the traffic. I'm going to start, based on certain percentages and thresholds that are, I think in general, are configurable to an extent. I'm going to start dropping different traffic classes sooner than 100%, so that the other traffic, the higher class traffic, will have more bandwidth theoretically. That's weighted tail drop. It's still tail drop, but it is weighted by class. The next level of sophistication is random early detection, right? So random is better because when you think about it, this comes under the category of congestion avoidance. So I want to do something before I get to 100%. And I could tail drop, right? That's we got weighted tail drop. But random early detection has 3 different sorts of actions that it will take. There's a no drop, random drop, and tail drop. And the no drop is you can have. It's also, of course, by it is also by IP precedence value. So what you do is you could say for certain classes, I'm not going to drop that traffic. And for other classes of traffic, let's say classic IP precedence value 3 or DSCP value, you can say, all right, when this hits a certain threshold, I'm going to randomly drop a certain amount of traffic, right? And then there's tail drop. For this type of traffic, we're just going to do a tail drop at a certain percentage. We also have load balanced handle traffic as well for you newbies. Yes. Yes, we do. All right, so then we have weighted random early detection. And, you know, I might have to go back and look at these guys because I was sort of describing weighted random early detection. I don't think I've distinguished those too well. Let me pull up this guide. This is a site, guys, where a lot of this info came from. There were, I think, 2 or 3 different articles I referenced, but this one was really good. I don't know how I came across. I don't know if this is maintained. Oh, here's this Aaron Balkunas. It says CCNP, but a lot of this stuff, the last guide was updated like in 2014. So, but this stuff has been around a while, and he had an article here that's really good about weighted random early detection, and it's a PDF. So let me just come to this. Okay, RED will randomly drop queued packets based on configurable thresholds by dropping only some of the traffic before the queue is saturated. Okay, sorry, I had that wrong, guys. And I'm glad I reviewed this. So the random early detection and weighted random early detection essentially do the same thing. You set thresholds, and then you say, okay, if I have traffic coming in and I'm near, I thought about earlier maybe I could draw this out. Let's do that. So let's say I have a queue and I have 100% threshold. And let's say I have 75% threshold and 60% threshold. So with random early detection, it is indiscriminate. And I thought I put that in here, and I regret not doing that earlier. But now that I've gone over it, I'm going to remember it better, right? So random early detection is going to say, all right, up to 60%, you know, we're going to do no drop of traffic. Actually, maybe there's just 2 thresholds here, right? Yeah, so we're going to do no drop up until 75%. So we're going to say here, no drops. When we hit 75%, all right, we're getting a little worried here. Let's say this is RED. Indiscriminate drops. All right, so we're at between 75% and let's say 95%. I don't know, it could be 100%. I don't know exactly how that works. So this will be a, this is no drops. Now when we hit 75%, we're gonna do random drops. And again, random drops could be, let's say I'm gonna start dropping 2 out of every 10 packets. That's going to help avoid the global. First of all, it's going to theoretically lighten the traffic load a little bit, depending on how aggressive the drop algorithm is. But at 75% at least, I could say, all right, I need to start doing, we want to avoid full congestion and tail drop and global synchronization with TCP. So at 75%, it's going to randomly drop packets. Those might be UDP. It's going to be random, right? It might be TCP. Inevitably, some of the TCP connections are going to back off to slow start. But at least it won't be a lot of the TCP connections at the same time, right? And that's fine because the slow start on TCP, it will catch back up at some point. Right? It will eventually, and there are algorithms to determine this, right? That's from some of the books you can read on TCP, but it will eventually hopefully catch up to a faster transfer rate. But that's the idea with RED, random early detection. 95%, no choice, right? We might have to do tail drop. And we're back to, the same as first in, first out, and the problems that come with that. Now, weighted tail drop is different. Weighted random early detection, because this is not just tail drop. That's the distinction, right? Tail drop is that. It's dropping it from the tail. Weighted random early detection, again, you have these thresholds, right? So you have a minimum threshold and a maximum threshold. And this is a little more sophisticated because you have what's called a mark probability discriminator, MPD. And this is a number that, let's say that it is 5. And I think that how that works is, let's see. Let's look that up again here. It has a formula here. Actually, it may not be in this one, MPD. MPD, I like to think of it as a buffer. A fraction, right, 1 over. Okay, I was doing it the other way around. So if the mark probability discriminator is 5, then it's going to say, okay, 1/5. So I'm in this area here, right, between random drops and tail drops, between my minimum and my maximum threshold. So at minimum threshold, let's say this is 75%, right? Same scenario, weighted random early detection. I'm not worried about dropping in it. This might actually be lower. That's probably a bad example. Let's say I'm not even near, I'm not even up to 60%. I'm not worried about dropping any traffic on purpose, right? But when we get above 60, then we need to start dropping some traffic randomly, like we would do with RED. However, using this mark probability discriminator, or denominator, sorry. Maybe that's why I got it wrong. I didn't have it named correctly. I could have swore I saw it named discriminator somewhere. Let's check. See, it says here, mark probability denominator. But that's in Learning Network. Sorry, guys, I gotta find this. Okay, here's the iOS QoS Solutions Configuration Guide. Google, you're telling me it's there, but it's not. All right, let's go to the, I know where to go. Let's go to the official cert guide. And let's see. What do you guys think it is? Anyone? Anyone? What's your bet? What's it going to be, guys? Is it denominator or discriminator? I'm going to volume 2. Nobody wants to venture to say, eh? Thank you, Show. All right, Show IP interface brief says denominator. That's what I'm tending to think too. That's why you got to be real careful where your sources are, right? Okay, denominator. Yeah, we're on a delay. Understood. Okay, I just try not to show the I'm doing a search here. Okay, how WRED. Okay, that's kind of annoying. I went to a chapter and it says MPD, but it does not. I think I can click on. I love when they throw out a term in the middle of a chapter and they don't describe that term. Mark probability. Detonator, I love that. Okay, guys, it is denominator. The mark probability denominator. And that's what it says here. I just saw it somewhere, though. Show got it right. Because we just did a search somewhere, and it came up with... It says denominator here. Someone just asking a question. This user just had it wrong. Yeah, quiz during the stream, right? Bonus points! Woot! Okay. Quiz every stream. Okay, quiz every stream. You know what? I may do that, man. I may do that. That's a great idea. And prizes. Actually, there is something I want to give away, guys. I haven't really announced it formally yet, but just because I've been, you know, counting down the days, but I have a blue snowball microphone that I only used for like a few weeks. So it is used, but it's in original packaging, and I've thought about giving it away because I've never returned it. But that was my intent, to return it and get the money back. But I'll probably do a giveaway of a blue snowball microphone. It wasn't bad. It's just I don't have the best, like the most resounding voice. So for some reason, it just wasn't. It wasn't working with my voice. But a lot of streamers use it. A lot of streamers use it. That's why I bought it. So for other people, it may work great. Anyway, mark probability denominator. What it does is it's like a denominator, right? Because you basically said, okay, for this traffic, I'm going to start dropping random drops 1/5 of the packets, right? And that's the thing. You can do it depending on the traffic type. That's why it's weighted, because you can say, all right, I'm going to have this denominator for this precedence value or DSCP value. Yeah, definitely appreciate the visuals. Visuals are always very helpful. You know what's good? You know what I do a lot sometimes? That's why chat is so great, man, because it gives you these ideas, you know. Groupthink. So I always love doing Google image searches. I find the best charts that way. Like images. Sometimes you just find these little gems, you know. And sometimes I'll do that when I'm desperate and I'm like, oh man, I need a visual. I'll just come out here and put in the acronym, call out whatever acronym you want. Here it is, WRED, right? Congestion avoidance in-depth tutorials. Select WRED profile based on IP precedence or DSCP. And of course, when we reach the threshold, right, that is assigned, we'll do a random drop. Here's WRED behavior by different precedents illustrated, right? Drop percentage. Yeah, good stuff here. So not the best explanation, but that should help. And actually going through it helped me a little bit. Oh, also, this is where your strict priority queues come in, because in general, your strict priority queues are not going to be, you could say for this particular priority of traffic, this particular marking, we don't want to do any random drops on this, usually voice, right? So yeah, this applies to standard queues. Strict priority queues are not dropped, and it is incompatible with weighted fair queuing. So you know how you do, you can have, and I should probably do another session on that, weighted fair queuing. I've been reviewing that as well. But you've got different types of queues. FIFO, first in, first out, and a priority queue, right? Well, weighted random early detection is really, you can only use it on a FIFO queue. And I think the command is random detect. I think that's the command. All right, guys. So if you want more information on that, check out those router alley guides. There may be some other good stuff in there too. And I'm glad I have this here linked on this date, so I'll be able to come back to it. If I get desperate too for something else, I might find a good gem in here. But that's really it. So tonight, I'm probably going to look at this WFQ. We might cover a little bit of that tomorrow. And is this used commonly with QoS? I wish I was a better person to ask, Banner MOTD. I'm very inexperienced with QoS. That's why I have had to do a lot of studying and research. And when I go to lab this, I'm going to have to lab this a lot, because honestly, I've not done a lot of work with this. So I know that, hey, thank you, mentors. Appreciate the comments, Mary. Have a great team. I've had a great time. 5 more days and counting. Yeah, man. Got to hit it. So I know that when you're doing class-based weighted fair queuing, Banner MOTD, at least from a lot of the examples I've seen, a very common thing to do is to do a priority queue for voice. I think a lot of the voice configurations I've seen like that, where you're going to say voice, you're going to give it bandwidth, let's say 20%, and you're going to say priority percent. So when you say priority percent, that means that is low latency queuing, and that traffic, not only are you allocating bandwidth, but it is a strict priority queue for that particular traffic, right? But you could have a different queue and have bandwidth allocated to, say, for example, web traffic, HTTP, or, if you're using NBAR, it's almost limitless, the type of traffic you can identify, right? But you could allocate a certain percentage, guarantee a certain amount of bandwidth, but it can be in a FIFO queue, and you can use weighted random early detection in that queue. So, it's not as harmful, and to avoid congestion, you can decide, okay, I do want to randomly drop. If I get congestion, I do want to randomly drop HTTP traffic, but I only want to drop, I want to use an MPD of, let's say, 10. So 1 out of every 10 packets. Whereas everything else, best effort traffic, right? Your IP precedent is 0. We're going to use a different MPD for that traffic class. It's going to go into a FIFO queue, first in, first out, not a priority queue. And we're not going to really guarantee any bandwidth, just whatever bandwidth is left over. And not only that, but we're going to have a higher MPD for class 0, right? Unmarked, essentially, 0. And we're going to say 1 out of every 5. We're going to randomly drop, so we avoid problem with HTTP, and especially avoid problems with voice. So I will say I have seen with voice priority queuing for sure. Whether that's used a lot with random early detection, again, probably not with voice, but with other traffic, that I don't know. There's some other really experienced people probably in the channel, though. Maybe that's a good question we can pose out to them and see. Mentor HQ, especially for VoIP and video conferencing, yeah. Very low tolerance of latency, right, and jitter, especially as that type of traffic. So, web traffic, you know, file transfers, FTP, not as big a deal, right? It's a great thing about QoS. Well, that's all I got, folks. Man, this has been 45 minutes, but it's been a good 45 minutes, I think. Same here, not a lot of experience in VoIP technologies. VoIP really drove QoS, I think, in the early days. Like when I've been in the industry a long time. I have not been doing a networking a long time. But I can remember when Cisco in particular and other vendors started really getting serious, started really rolling out voice solutions. That's when I saw companies. I was at a company too. We were looking at doing converting to VoIP. Some of you, a lot of have been doing that. Show says, thanks, Tamer, keep up the great work. I'm dropping off. All right, man, get better, Show. Get better, bud. I know you want to get back to labbing as soon as you can. Thank you. But yeah, I remember the company when we made that transition from digital to VoIP. And one of the things that, I was at a hospital and they had one of the main applications, of course, was the, we had an EHR, a medical health record system. And one of the requirements before even Cisco came in, they were heavily involved. They wanted our business. So, they were proposing not investing any more equipment or money in the legacy digital system, it was reaching its physical limitations too. We're going to have to get like another system. They said, hey, let us sell you a VoIP system. But one thing we're going to need to do is, we're going to need to forklift upgrade your entire network because we need to implement your network you have now won't handle it, and we can do quality of service on a new network, right? So I think voice, it's been in my experiences, has driven a lot of these QoS technologies in the enterprise anyway. I'm sure service providers have been using it a long time in different forms, right? But before they did that, they said, okay, we need to do a network assessment. And they came in and they did some telemetry, and they said definitely, your network now won't handle it. So yeah, voice has been a big driver, and now even more video. How many of you all have video phones? Like I'll tell you right now, I have at home. And I'm a remote worker. Our company has a lot of remote workers. And some people use soft phones. I was in an office before, and so when I went transition from office to remote, I was always near the telco guys, by the way. And it was like, hey, you're a networking. If you take care of us, we take care of you. So I always was able to test all the newer phones and stuff like that. So I had one of the early was one of the early testers for a video phone. And when I came remote, transitioned to remote, I took my phone with me, and it works great. So I don't know how many of you are using a video phone at your job. Yep, I just had to implement video conference a few weeks back. Big headache, most def. What's a headache is doing the conference rooms. The video conferencing, that's like a different ball game, right? Some of that equipment is really cool. Cisco sells it too. They sell where it'll follow the speaker in the room and things like that. But it can be a pain to integrate it into WebEx, and yeah. It's funny, anytime anybody did a presentation, even when I was back doing desktop support, I would always plead with them, please come early. And let's test it, make sure everything works, because inevitably something always goes wrong in a video conference presentation, right? Like, it's either the sound or something's not hooked up right, and that's always funny when that kind of stuff happens. It's funny to the people watching it. Anyway, that's going to wrap up pretty much our review of congestion avoidance today. And tomorrow we'll see what we go over with. I don't know what I'm going to hit tonight. Yep, I know Cisco vendors to help on an alternate call. Yeah, that's always the worst, man. But yeah, I'm going to be hitting Boson tonight. I'm about 2/3 of the way through it. And when I'm hitting stuff like this that I know I don't have down as well as I need to, I go over it, and some of these I'm going to mark for a little more in-depth review tomorrow as I have time. All right, so I don't know what it is yet. Maybe weighted fair queuing, class-based weighted fair queuing. We'll see. But this is a great blog, guys. If you haven't read it yet, guys and gals. Tim, who's Carpe DMVPN. Thank you, mentors. You have a great night as well, guys. Everybody in here. Banner, Show, Big Abe. The regulars, man, I hope things are going well. And everybody give a shout out to Big Abe. He's thinking about doing a stream here soon on some really cool data center stuff. So maybe we can talk him into it. Wink, wink. But check out this blog. This is part 3, and this is going to be really helpful going into the lab prep. BGP Convergence blog. Banner and I have been going back and forth, just kind of looking at, it's a big subject of interest to me right now for reasons to do at work. Part of the complaints I've had with, catch you later. L. Harris is here too in the house, and we also had earlier Delta War, our sub Delta War. So, man, great chat tonight, guys. But yeah, BGP Convergence blogs. This is really good, and BGP, Convergence, in particular, when you think about an MPLS cloud, when that MPLS provider is handing you a link, and they're saying, okay, remote site A out in California, here's your link there, hook up your router, you can peer with me BGP if you like, and, I'm going to peer you on the other end. Let's say you got a data center 1 over here. Great, right? But that's a real simple way to do it. But there's so much complexity with BGP when you talk about convergence, multipathing, and that's been a big thing of interest to me. And we've been relying somewhat on an MPLS vendor for some of the policies on what happens with our routes, that we're giving them. And we haven't been super happy with some of the things and the response times on, some of the policies they've had with the routes once they leave our network and go into the MPLS cloud. That's one of the reasons I've actually been doing some GRE tunnels lately. Just taking the policies into our own hands. It's a workaround until we get either them straight or we go to another technology like Viptela. So this has been of real interest to me, and I know Banner both has been labbing and studying some things on this. So this is a good article. I skimmed it. I didn't read all of it, but it looked good on the surface already. And then, of course, check out Tony E's 100 Days of Labbing. Thanks for all your support, guys. Hope you have a great night. Guys and gals, we shall see you tomorrow back here, same time, 7 p.m. Eastern. Sending you all the good bits. Thanks, folks, for the support on the channel, for the follows. Got several follows here recently, and subs. If you have that free, if you're shopping Amazon Prime Day or trying to catch those deals still, don't forget about your free Twitch Prime account that you get with your Amazon Prime. Just hit that sub button and you support the channel. Thanks for all the support, guys. 6 days, we're going to keep hitting it. Have a good night. We'll see you back here tomorrow on the Land Tamer stream.